Okay, Mackenzie and Aiden, I got like almost to the end of what we did today, and then I realized I wasn't recording. Sorry. So we're on 2-4. We started. I'm just gonna re-record what we did because it wasn't very much. 2-4. We're in the second half. This is not very much. They talk about average rate of change. An average rate of change would be like miles per hour, or like meters per second, or like a rate, whatever, a rate of change, something per something. And average rate of change is another way of just saying slope. Okay, so you're doing like y2 minus y1 over x2 minus x1. That's all you're doing, okay? So here in this example, they said in 2013, Amazon spent this much. In 2017, Amazon spent this much. The thing to keep note of is that these are both in the same units, so like millions and millions. If they're not, you want to switch them to be the same, but this one's okay because they're both in millions. So I went ahead and wrote those out as an ordered pair. So 2013, comma, 6565, and then 2017, comma, 22,620. And then from there, when they ask for average rate of change, you're just finding the slope. So we subtracted those. That was this much divided by 4, and that was this much, okay? And then this is your unit, or your average rate of change. When it says interpret the results, this is how many $1 million it is increasing per 1 year, okay? Over 4 years, it increased 16,000 million, basically, right? So it'd be like 16 billion, basically, in 4 years, which made, this is 4,000 million, which is actually 4 billion. That's a decimal, by the way. 4013.75 million, which is actually 4 billion. So that's the amount that it increases per 1 year. That's your average rate of change, okay? So just how much it's going up and over per 1 year instead of per 4 years, whatever, okay? Now they will also do this for a function that's not linear, so this one looks kind of more exponential. But what we do is we just plot 2 places on the graph, and then we just approximate it with a linear function, so that red line. So we're just saying what's the average rate of change, like obviously it's increasing more from here to here than it is from like here to here, right? Like those slopes are different. But when they say average rate of change, we're just averaging it out from here, from this dot to this dot. Let's find the average, okay? So all you're doing is you're taking these two and you're finding the slope, okay? Now it doesn't matter what order you subtract them in, just as long as like they go together. So like we did this one minus this one over this one minus this one. I always do like kind of I go from left to right. So the right point minus the left point. But if we did this backwards, it would be fine. We could do this guy. We could switch these two around just as long as we switch these two around. And if that's the case, we would ended up with 2 negatives that would cancel out. So we'd end up with the same answer, okay? So totally fine. If you want to subtract them backwards, that's fine. No problem. So when we did that, divided by 17, we got 134 billion per year. So we're talking about dollars per year. This is how much they've spent on healthcare, federal spending on healthcare, 134 billion per year, whatever. So, and then they say interpret that. That's how much they spent per 1 year versus over the course of 17 years, okay? Last thing that they talk about is a cost function versus a revenue function. And we said that profit is revenue minus cost, right? So the amount that you're charging per item minus the cost it takes. So like in Fab Lab, the revenue is how much we're charging per shirt, right? The cost is how much it costs us from Jiffy to make those shirts, or how much the transfers cost. We just subtract that out, and we want to make sure that we're making a profit, right? So that's kind of how we do that. Example 10, they have some stuff going on here. Assume that the cost of production, they want us to do 4 parts. They want us to first find the cost equation, then find the revenue equation, then find the profit equation, and then they ask a follow-up question on part D. So it says, assume that cost to produce an item is a linear function, meaning that it doesn't cost more or less if you make tons of orders, like in Jiffy. It's not technically linear because the more shirts we purchase, the cheaper the shirts are. Like we get like a bulk discount. So where they're saying linear function, Like regardless of how many shirts we buy, they're all gonna be $3 a piece. They're not giving us like a bulk discount the more that we order, right? It's a linear function, that type of thing, okay? The fixed cost is $1,500. This is like my setup fee, okay? How much I'm getting charged no matter what. And the variable cost is $100 per item. Okay, so we went ahead and we hopped down here and we said, okay, that means that my cost is gonna be 1,500 plus 100 times X, whatever that ends up being, right? However many items I produce. That's how much it's going to cost me, okay? I'm selling those items for 125. That's gonna have to do with my revenue, so that goes down here in part B. That my revenue is 125x, that's how much I'm making per item. And then when we go to write our profit equation in part C, it's revenue minus cost. So we took 125x minus this equation, and you just have to be careful because we have to distribute that negative through. So 125x minus 1,500 minus 100 makes a total profit of 25x minus 1,500, okay? So my profit equation, maybe I should write that over here, profit is 25x minus 1,500. And again, it's 25 because it was 125 minus 100. Okay, so this is my final profit equation. And then in part D, it says how many items must be sold before we make a profit. Well, if we want to break even, we plug 0 in for P. And then we added the 1,500 over, which is right here. We added 1,500 over, and we ended up with this thing going on, right? If we divide by 25, we would have to sell 60 items just to break even. So when it asks for how many items must be sold for the company to make a profit, more than 60, okay? Otherwise, we're losing money, right? So there is how that works. Now, how do you offset that? How do you make it so you can make a profit sooner? Charge more per item, or figure out how to reduce your cost, right? Like go with a different company that's selling shirts for $1 a piece instead of $3 a piece. I don't know. Or up your prices, that type of thing, okay? And then that would make it so that you are making a profit before the 60 item mark or whatever. So anyway, whatever. So all linear functions, average rates of change, slopes, all that stuff, okay? Not too long today.